Hello students, today we discussion about law of conservation of linear momentum. But before this law, we discussion about Newton's second and third law and also momentum. Just a small point of view discussion. According to Newton's second law, F is equals to mass into acceleration. Mass into acceleration, how to calculate acceleration? M v minus u upon t. So what is v minus u? That is the difference of final velocity minus initial velocity divided by time. That is called acceleration. So just I put on the new formula of acceleration and the value is changed. Okay. We use this law in the law of conservation of momentum, and also we discussion about the momentum. Momentum, that is denoted by the symbol P, and P is equals to basically mass into velocity. This is the formula of momentum, and mass, their unit is kilogram, and velocity, their unit is meter per second. So I also explain what is the unit of momentum, kilogram meter per second. Is that clear? So basically these two formula we use law of conservation of linear momentum. Okay. So just I explain what is the conservation of momentum. Conservation of momentum. So basically conservation means the momentum, their value does not change, and momentum, in a discussion before this lecture, momentum basically that is the product of mass and velocity. So just we come back our point, what is the law of conservation of momentum? According to this law, if the external force of in a system is absence, then absence of this external force in this situation, the total momentum before collision and after collision is unchanged. Is that clear? So I take one example. Take two objects. This is the one object and this is the second object. The first object, their mass is m1, and the second object, their mass is m2. Both objects moving same direction linearly with initial velocity u1 and u2. If I ask u1 their velocity more than u2, definitely this object is strike to m2 mass of object. So this is striking time. So striking time, this object, their mass is m1. It is applied force m2. So what is their force? F12. Then m2 mass of object is also given reply, that is called F21. So F12 and F21, actually this is the action and reaction. All of you study Newton's third law, which is every action equal and opposite reaction. This m1 mass of object, that is strike to m2 mass of object. So m2 mass of object is also given a reaction F21. Then after striking, both objects are separate, m1 and m2. So what is changes? What is the changes after striking? Definitely their velocity. This situation, their velocity u1, after striking their velocity is v1 and their velocity is v2. So first we calculate what is the value of F12 and what is the value of F21 according to Newton's third law. According to Newton's third law, F12 that is equal to F21, but that is the minus sign. Minus sign is indicate opposite direction. This force, their value is opposite to F12. So first we calculate F12. What is the value of F12? See here. According to Newton's third law, second law, F is equals to ma. So with the help of this formula, we calculate F12, that is M1 A1, that is the value of F12 is equals to minus F21, so that is the FM2 A2. Because F12, that is the force effort by M1 mass of object, so multiply by their acceleration, and F21, that is the force effort by M2 mass of object, then their mass multiply by their acceleration. Just we calculate their acceleration. M1 A1, what is the value of A1? Just the formula of V minus U upon D. So what is the initial velocity M1 mass of object? U1. After striking, what is their velocity? V1. So V1 minus U1 upon T, this is the value of A1, minus M2, and this is V2 minus U2 upon T. Look at here, V2 minus U2 means the second object, this is their initial velocity and this is their velocity change. So in this equation T and T, that is same value, then just open the bracket, M1 into V1, M1 V1 minus M1 U1, and this is also open the bracket, minus M2 V2, minus and minus plus, because I open the bracket, so this is M2 U2. Look at here, I open the brackets, M1 V1 minus M1 U1 is equals to minus M2 V2, and this minus definitely it is plus M2 U2. Is that clear? So this M1 V1 and this M2 V2 transpose here, so definitely this minus is plus M2 V2 equal, this M1 U1 is transpose right hand side, M1 U1 plus M2 U2. Just I follow the transpose rule. So according to transpose rule, this negative is positive and this negative is also positive. So I category wise revise, that is the final momentum after collision, and that is the initial momentum before collision. So just I arrange M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So I want to say with the help of this formula, M1 U1, this is the momentum of M1 mass of object, M2 V2, this is the momentum of M2 mass of object. Their sum is unchanged. Why? Because that is equal to the momentum of both objects after striking. That is the message of this conservation of law. According to conservation of momentum, both forces acting in opposite direction means the net force is 0. Is that clear? So that's why that is momentum is unchanged. Thank you, students.